Below is the sketch of a function f of x. We want to sketch the graph of the derivative of this function f prime of x. So let's take a look at this graph. Okay, starting from negative infinity, we can see that the graph starts to decrease. And then at negative 3, there's a turning point, and then it starts to increase. And then it increases when x is negative 1, there's another turning point, and then it starts to decrease. And then here at 2, it levels off again, so there's a turning point. And then it starts to decrease again to where x is 4, and then it increases. These are the things that we need to make sure that we focus on whenever we sketch the graph of the derivative of a function. Now, at first glance, this seems to an all but impossible task. However, if you have some basic knowledge of the interpretations of the derivative, you can get a sketch of the derivative. It will not be a perfect sketch for the most part, but you should be able to get most of the basic features of the derivative in the sketch. Now let's start off with the following sketch of the function with a couple of additions. Okay. Now I want you to notice here that in the second part here, the peaks and valleys, okay, the peaks and valleys or the local minimum or the local maximums, we are drawing a horizontal line. So when you draw a horizontal line, okay, what kind of slope does that represent? Well, we know that that slope is 0. So here we have a slope of 0. Here is a slope of 0. Here is another slope of 0. And here is another slope of 0. Okay, so now at what values of x is it showing that it has a slope of 0? Well, here at negative 3, we can see that it has a slope of 0. Okay, at negative 1, we also see that it has a slope of 0. And then here at 2, we have a slope of 0. And then again at 4, we have a slope of 0. So, again, here are our slopes. Now, I also want you to pay attention here. Now, what would the slope go from here to here is another thing that we need to think about. And then from here to here and so on. But currently right now, we just want to look at where are the slopes equal to 0. So, notice that at x equals negative 3, x equals negative 1, x equals 2, and x equals 4, the tangent line to the function is horizontal. This means that the slope of the tangent line must be 0. Now we know that the slope of the tangent line at a particular point is also the value of the derivative of the function at that point. Because remember, the derivative is the slope. Therefore, we know the following. We know that f prime of negative 3, it's going to equal 0. F prime of negative 1 is going to equal 0. F prime of 2 is going to equal 0. And f prime of 4 is going to equal 0. Now, this is a good starting point for us. It gives us a few points on the graph of the derivative. It also breaks down the domain of the function up into regions where the function is increasing and decreasing. And we know from our discussions above that if the function is increasing at a point, then the derivative must be positive at that point. Likewise, we know that if the function is decreasing at a point, then the derivative must be negative at that point. Now, we can now give the following information about the derivative. Okay, so let's take a look at the first part here. So, when x is less than negative 3, okay, what is the function doing? Well, the function or the slopes are decreasing. So that tells us that whenever x is less than negative 3, we know that derivative of that function, or the slopes, is decreasing because it's a negative slope. Okay, so if you take a look at the line or the tangent lines that you would have on this curve, the tangent lines would represent a negative slope. Now, if we take a look at the interval between -3 and -1, well, what can we say here? Well, at this point here, well, our slopes start to increase. That means our derivative, so whenever, again, x is in between -3 and -1, we know that our slopes are going to be greater than 0, meaning they're going to be positive, because the tangent lines that you would have on that curve are going to be positive. Okay, next, we want to take a look at the values of when x is in between -1 and 2. So in between -1 and 2, we can see that the function, okay, is going in a decreasing direction. And since it is decreasing, we know that our tangent lines on that curve are going to be negative. So that means that f prime of x is going to be less than 0. Now, if we continued on the interval between 2 and 4, so if we go in the interval between 2 and 4, okay, once it gets to the 0 here, then it's going to start to decrease again. And as it's decreasing, again, if we put a line or a tangent line on that specific curve, that means our derivatives or our slopes are going to be negative. Okay, and then if we look at the last one here, this is where x is greater than 4. So if we take a look here, you can see that this function, if you found tangent lines on that curve, we would say that the slopes are increasing. So let's summarize here. Okay, if the derivative of f of x, the f prime of x, the derivative is less than 0, that means the tangent lines have negative slopes. If the derivative, or f prime of x, is greater than 0, then the tangent lines have positive slopes. So this is telling us where it's increasing and decreasing when we're looking at the graph. So now, before we go any further, let's plot our points on the derivative graph, where we know that we have f prime of -3 is equal to 0, f prime of -1 is equal to 0, and so on. So let's go ahead and do that. So here are our points here. So we know that on this graph, we have the following ordered pairs. And again, it's crossing the x-axis here. So we know that at f prime, we have -3 and 0. Okay, and then we have f prime of -1, and that's 0. Okay, and then at 2, we also have it's equal to 0. And then at 4, it's also equal to 0. Now recall that the reason why these are zeros is because we know that the horizontal lines at the peaks and valleys tell us what that slope is going to look like. Now, remember that we are given the signs of the derivatives here, and these are solely a function of whether the function is increasing or decreasing. The sign of the function itself is completely immaterial here and will not in any way affect the sign of the derivative. This may still seem like we don't have enough information to get a sketch, but we can get a little bit more information about the derivative from the graph of the function. So now let's take a look at the first one here, where x is less than -3. When x is less than -3, we know that the derivative must be negative. However, we can also see that the derivative needs to be increasing in this range. It is negative here until we reach x equals -3. And at this point, the derivative must be 0. The only way for the derivative to be negative to the left of x equals -3 and 0 at x equals -3 is for the derivative to increase as we increase x towards x equals -3. So that means that we are here to the left of 3. Okay, we are increasing until we get to that 0. And again here you can see that below the x-axis, we can see that this represents our negative. So therefore, we can see that the function is now increasing towards -3. Okay, now in number 2, what happens to the derivative? Well, the derivative increases. So in 2, when x is in between -3 and -1, we know that the derivative must be 0 at the endpoints of 3 and -1. And directly to the right of x equals -3, the derivative must be also increasing because it starts at 0 and then goes positive. Therefore, it must be increasing. So the derivative in this range must start out increasing and must eventually get back to 0 at x equals -1. So we have a rough sketch of it increasing and then going back to -1. So at some point in this interval, the derivative must start decreasing before it reaches x equals -1. So we're going to go up and then decrease. Now we have to be careful here because this is just general behavior here at the two endpoints. We don't know where the derivative goes from increasing to decreasing, and it may well change between increasing and decreasing several times before we reach x equals -1. All we can really say is that immediately to the right of x equals -3, the derivative will be increasing, and then immediately to the left of x equals -1, the derivative will then be decreasing. So let's take a look at 3 and 4. 3 and 4, we know that x is going to be in between -1 and 2. Where the derivative is going to be less than 0. So the lines have negative slopes. And in 4, x is going to be in between 2 and 4. We know that the derivative is going to be less than 0. So when x is in between -1 and 2 and between 2 and 4, we know the derivative will be 0 at the endpoints and negative in between. Also, following the type of reasoning given above, we can see in each of these ranges that the derivative will be decreasing just to the right of the left-hand point and increasing just to the left of the right-hand endpoint. So recall from number 2, we know that to the left of x equals -1, we know it's going to be decreasing. So it's decreasing. Okay, now we don't know where it's going to start increasing on the y-axis, but we're just making this a rough sketch. But we know it's got to come back to 2 because we know that it's got to get to 0 again. So therefore, it's going to get back up to 2. So it starts to increase back up to 2. Okay, and then again, we are going to be decreasing because we know that our derivative is still below the x-axis. So it's decreasing again, and then again we're going to have to go back up to 4. Because again, we need to get through this particular value of f prime of 4 is equal to 0. Okay, now if we look at the last one, number 5, x is greater than 4. That means f prime of x is greater than 0. So when x is greater than 4, we know that the derivative is 0 at x equals 4 and positive to the right of x equals 4. once again, following the reasoning above, the derivative must also be increasing in this range. So therefore, there is increasing. So again, this is a rough sketch, okay? And again, it's not precise. You're looking at the values of x to get this particular sketch. Now, putting all of this together and always taking the simplest choices for increasing and or decreasing information, it gives us the following sketch for the derivative. So here is our derivative of what we sketched up there. Okay? Now, note that this was done with the actual derivative, and so is in fact accurate. Any sketch you do will probably not look quite the same as you saw with my sketch. The humps in each of the regions may be at different places and or different heights, for example. Also note that we left off the vertical scale because here, given the information that we've got at this point, there is no real way to know this information. Now, that doesn't mean, however, that we can get some ideas of specific points on a derivative other than where we know the derivative to be 0. To see this, let's check out the following graph of the function. Not the derivative, but the actual function. So this was our first graph. Okay, so let's take a look here at -2 and 3. So at x equals -2 and x equals 3, we've sketched in a couple of tangent lines. Now, we can use the basic rise, run, slope concept to estimate the value of the derivative at these points. Let's start at x equals 3. We've got 2 points on the line here. We can see that each seem to be about 1/4 of the way off the grid line. So taking that into account and the fact that we go through one complete grid, we can see that the slope of the tangent line, and hence the derivative, is approximately -1.5. So the slope here, we can say, is approximately -1.5. Now, at x equals -2, it looks like, with some heavy estimation, that the second point is about 6.5 grids above the first point. And so the slope of the tangent line here, and hence a derivative, is approximately 6.5. So here is the sketch of the derivative with the vertical scale included, and from this we can see that in fact our estimates are pretty close to reality. Now note that this idea of estimating values of derivatives can be a tricky process and does require a fair amount of approximations, so while it can be used, you need to be careful with it.